let's check the answers. Okay. I should have got you to check the answers so I don't go too far with that all being wrong. What year was that? 2013? No, 2011. 2011. And what question? 22. Ooh. I don't actually have the question number. Oh, they've just asked for a velocity ratio. They haven't asked for the load like I asked. So you can see they've given the same velocity ratio. Again, they've written in a really confusing way. So what they've written here is they've written 250, right, which is the radius, and then they've said 600, which is the diameter. And rather than halving the diameter, they've halved the gear. So they've taken that 240 and halved that 240. Yeah. And then on this side, they've kept the 80. I do not like the way they've shown working out. But you know what? It's an answer, and at least I can see that I got that right. So, oh, okay, so well, that's interesting. Okay, so the top question, I figured out E, but what they wanted for the question above, I'm glad I still looked at the answer. Okay, so they've done the cos part, but then they say they want minus t times 280. So, calculate the force applied to the chain. Okay, so important that I got this first part of the question wrong. So I calculated the L correctly, and I don't know how many marks this is worth. I'd have to zoom out to see how many marks it's worth. What they actually were interested in, so we said that this here was 606, yeah? But then they wanted to know what is the force, if this is the force being applied here, then what is the force being applied to that part of the chain? So the idea is it's like having a lever like this that says 606, that's 250, while then having another force, you know, I'm going to write this better. I've never liked this question. Okay, it looks like this. So I've got 606 versus the force in the chain. This distance here is 250, and this distance here is half of 240. What's half of 240? 120. Yeah? So for the sum of the forces to be equal, what we need to say is, so for the sum of the moments equal 0 from the, we'll call that point X, what do we know? We know 0 equals 606 times 250. And then, is that going clockwise or anti-clockwise? Anti-clockwise, so I'll put a minus there. And then this force here is going to be Fc times 120. Right? And so we bring this one over here. I don't have my calculator anymore. .606 times 250 divided by 120 equals 1262 newtons. That's the force on the chain. Okay, so I'm aware that I would have got that one, and I've done this question multiple times. I've done it every year for a couple of years now. The force on this applied to the chain, I've got to really read that it's the force applied to the chain, not the force applied to the pedal. Now, I would be angry that I got that wrong, but the key here is learn from my mistakes, right? And make sure that when you go into the exam that you're reading the questions really carefully. right? You can't get the answers right if you don't read the questions properly. Okay, so that's everything we need to know about efficiency.